In section 12.3, we'll look at geometric sequences and series. PreCalculus Online starts right now. In section 12.3, we look at geometric sequences and series. So this is sort of the exponential analog to arithmetic sequences. If arithmetic were linear, then geometric is exponential. So let's go ahead and define geometric sequences. A geometric sequence is a sequence where each successive term is found by multiplying the previous term by the same number. Called the common ratio. The common ratio is symbolized by r, and we have a restriction that r cannot be equal to 0. So the terms of a geometric sequence are a sub 1 times r, a sub 1 times r, and then to get the next term you would multiply by r again. Well, that just produces a sub 1 times r squared, and so this is where the powers come in, and the exponential. So it's a sub 1 times r cubed for the next term, a sub 1 times r to the fourth, etc. Of course, a sub 1 stands for the first term. Let's look at example number 1. Determine if 2, 6, 18, 54, 162 is a geometric sequence, and if so, what is its common ratio? So again, we're going to look at the, so it's not the difference this time, but it's the ratio. So we do 6 over 2, and that's equal to 3. 18 over 6, that's 3. 54 over 18 is equal to 3. And yes, you guessed it, 162 over 54 is equal to 3. So the common ratio is 3. The formula for finding the nth term of a geometric sequence is a sub n is equal to a sub 1 times r to the n minus 1. So again, it's sort of similar to the previous result about arithmetic sequences, where we had n minus 1 times d. This time we have the n minus 1 serving as the exponent. Example number 2. Find the 8th term of the geometric sequence 8, negative 4, 2, negative 1. So here we have our alternating sequence, which is fine. And what is the common ratio? Well, we're given that it's a geometric sequence, so I only really need to check one ratio, and that's negative 4 over 8, so it's negative 1/2. So the 8th term, using the formula above, would be a sub 8 is equal to the first term, which is 8 itself, right here, times the common ratio raised to the n minus 1 power. So that would be the 8 minus 1 power. So that would be 8 times negative 1/2 raised to the 7th power. Now when you do this, remember to use the order of operations, and the power part has to come first. So this is going to be 8 times negative 1/2 to the 7th power. That's negative 1 over 128, which is then equal to 1 over 16, negative 1 over 16. Example number 3. Let a sub n be a geometric sequence. If a sub 3 is equal to 15 and a sub 6 is equal to 1,875, what is the nth term formula? All right, so let me use the nth term formula in general. So it's going to be a sub n is equal to a sub 1 times r to the n minus 1. Now my first piece of information I want to use is a sub 6 is equal to 1,875. Using this piece of information, I know that a sub 6 is equal to a sub 1, which is unknown, times r, also unknown, raised to the 6 minus 1 power. So 1,875 is equal to a sub 1 times r to the 5th. All right, hold on to that. Next, we know that a sub 3 is equal to 15. So that means a sub 3 is equal to a sub 1 times r to the 3 minus 1 power, or 15, is equal to a sub 1 times r squared. Now, I have two equations and I have two unknowns. So I can use these together to figure out some information. And the way you do that is through division. So I'm going to take 1,875 and I'm going to divide it by 15, and that's equal to a sub 1 times r to the 5th power divided by a sub 1 times r squared. (1,875) divided by 15 is 125. The a sub 1's cancel, and then r to the 5th divided by r squared is equal to r cubed. So this tells me that r is equal to 5. Now I still need to find the first term of the sequence, and I can use any of my previous equations. I'll use this one with the 15 because it has smaller numbers. So 15 is equal to a sub 1 times 5 squared. So 15 is equal to a sub 1 times 25. So a sub 1 is equal to 15 over 25, which reduces to 3 over 5. So a sub n, the sequence, is given by the nth term formula, 3/5 times 5 to the n minus 1 power. Next, we look at the sum of the first n terms of a geometric series. So again, a series is the sum of the terms from a sequence. Let's go ahead and develop the formula. We'll still use S sub n to denote the sum of the first n terms, but in this case, it's the sum as k goes from 1 to n of the general formula for a geometric sequence, the general terms here. So that's a sub 1 times r raised to the k minus 1. So the exponent is what changes because the a1 and the r are fixed. It would be a sub 1 times r to the 1 minus 1 plus a sub 1 times r to the 2 minus 1 plus a sub 1 times r to the 3 minus 1 plus ... all the way up to a sub 1 times r to the n minus 1. Well, I can simplify this just a little bit. We can say that this first term is actually just a sub 1 because r to the 1 minus 1 is r to the 0, and r to the 0 is 1. Plus a sub 1 times r plus a sub 1 times r squared plus dot 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 all the way up to the last term, a sub 1 times r to the n minus 1. So that's the sum as it is. Now to develop the formula, I need to pull a little trick here. So we say then what we want to calculate is r times s sub n. So I'm just going to take all the terms from the previous line and I'm going to multiply them by r. The first one, we just tack on an r, a sub 1 times r. But for the second one, r times r becomes r squared. For the third one, r squared times r becomes r cubed, dot, dot, dot. And our last term now becomes a sub 1 times r to the n, because r to the n minus 1 times r is r to the n. And then, for our trick, we need to find s sub n minus r times s sub n. So we're going to do s sub n, and I'll just rewrite this right here, is going to be a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus dot 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 all the way over to a sub 1 times r to the n minus 1. And then we'll have the next sum here, the r times s sub n. And those terms start with a sub 1 times r. So I'm going to line it up under the a sub 1 times r term from the previous line. And all these sort of line up. Here we have a sub 1 times r to the n minus 1, but then there's another term after that. It's a sub 1 times r to the n. And now the trick is to subtract these, because that's what we want to do, subtract. Subtracting just changes all the signs here. And what happens in the middle? Well, the a sub 1 times r term cancels. The a sub 1 times r squared term cancels. All of the terms cancel in the middle, including this second to last term, a sub 1 times r to the n minus 1. And we're left only with s sub n minus r times s sub n is equal to a sub 1 minus a sub 1 times r to the n. Solving for s sub n, the first thing I need to do is factor on the left side, and that's going to leave me with s sub n times 1 minus r. Factoring on the left, I can factor out a sub 1, and that leaves me with 1 minus r to the n. And here it is. S sub n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. And that's the formula for the sum of the first n terms of a geometric series. Example number 4. Find the sum of the first 10 terms of a geometric series whose first term is 5 and common ratio is 2. All right, so the nth term formula says that we have a first term of 5 and a common ratio of 2. So it would be 5 times 2 raised to the n minus 1 power. To find the sum of the first 10 terms, let me use the sum of the first n terms geometric series formula. And that would be a sub 1 times 1 minus r to the n divided by 1 minus r. And so s sub 10 is equal to the first term, which is 5, times 1 minus the common ratio, which is 2, raised to the 10th power, because 10 is n, divided by 1 minus 2. this works out to be 5 times negative 1023 divided by negative 1. Negatives cancel, and you multiply this out, and you get 5,115. Let's look at example 5. Find the sum. The sum as k goes from 1 to 8 of 20 times 1/2 to the k power. So the first thing you need to notice is that this is not quite the a sub n term formula. It's not quite in the right format. It has a power of k, and this should normally be a k minus 1. So we just have to take a little precaution when we work with our formula. So remember that the sum formula is S sub n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. I need to actually compute what a sub 1 is going to be. It's the first term of this sum, and since it starts with k equals 1, I just find that by plugging in k equals 1 into the formula. And so 20 times 1/2 to the first power is just 10. So it may look like the first term is 20, but it's not in the right format, and the actual first term is 10. So we have to use that instead. So S sub 8 is equal to a sub 1, which is 10, times 1 minus 1/2 raised to the 8th power divided by 1 minus 1/2. This works out to be 10 times 1 minus 1 over 256 divided by 1/2. To simplify this, we can multiply by 256 over 256. And that's going to be 10 times 256 minus 1 over 128, which equals 1,275 over 64. Next, let's talk about the infinite geometric series. So the notation for this is going to be the sum as k goes from 1 to infinity. So instead of having a finite number as the upper limit, like n, we're going to say that this goes to infinity. And the term that we want to use here is a sub 1 times r to the k minus 1 power. Now what this technically means is a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed plus ... And it's sort of like you're taking an infinite number of terms and adding them all together. Now what this technically means is that as I continue to add more and more terms to my sum, the sum approaches a certain finite number, and the more terms I add, the better the sum gets toward that number. Of course, it's impossible to actually add an infinite number of terms, but that's sort of the meaning of what is going on here. Now, how would it actually approach this number that is going to be the sum? Well, it only happens if the ratio that we're talking about here is less than 1 in absolute value. So that basically means that negative 1 is less than r is less than 1. And of course, we've already excluded r is equal to 0. So if this is the case, if the absolute value of the common ratio is less than 1, then the series converges and S is equal to A sub 1 divided by 1 over R. So that's the formula for an infinite geometric sum. Otherwise, the series diverges. So converges means that you can actually get a sum, and diverges means that you cannot get a sum where, as you keep adding terms, it approaches a certain number that we call the sum. Example 6. Find the sum. 1 plus 2/3 plus 4/9 plus 8/27, etc. So here we have an infinite geometric sum. Let's go ahead and find the common ratio. So the common ratio is the ratio of any two consecutive terms. So this would be 2/3 divided by 1, which is 2/3. And so the sum is equal to the first term divided by 1 minus the common ratio. Well, the first term is 1, right here. And then this is divided by 1 minus the common ratio of 2/3. So this is 1 over 1/3. And that's basically asking for the reciprocal of 1/3, which is 3. Example 7, find the sum. The sum is k goes from 1 to infinity of negative 1/4 k. So let's verify that this is going to converge. The common ratio is negative 1/4, which in absolute value is less than 1. So we're going to have the sum is equal to a sub 1 divided by 1 minus r. I need to compute what the first term is going to be. No problem. I'll use k is equal to 1. And so we get negative 1/4 raised to the first power, which is negative 1/4. So this is equal to negative 1/4 divided by 1 minus the ratio of negative 1/4. Another technique that you can use to solve these, instead of dealing with fractions and fractions, is to multiply by 1 in the form of the denominator over the denominator. We're talking about the little denominators here. So negative 1/4 times 4 is negative 1. The 4 here distributes to here and here. And that's going to give me 4. The two negatives cancel to make a plus. And then a 1. And that's just negative 1/5. So this sum does converge, and it converges to negative 1/5. Let's look at example 8. Determine if each geometric sum converges or diverges. If it converges, then find the sum. Let's look at example A. Find the sum as k goes from 1 to infinity of 1/3 times 4/3 raised to the k power. Well, this is geometric. However, because r is equal to 4/3, remember that r is the quantity raised to the power. This is equal to 4/3. Well, this is greater than 1, and so therefore this sum is going to diverge, meaning it's not going to have a sum. Let's look at part B. The sum as k goes from 1 to infinity of 4/3 times 1/3 to the k. Well, in this case, the r is equal to 1/3, and that's less than 1 in absolute value, so this one does converge, and we can find the sum. The sum of the infinite series is the first term divided by 1 minus r, the ratio. I need to compute what the first term is, so I'll use k is equal to 1, and this will be 4/3 times 1/3 to the first power, which is 4/9. So this is equal to 4/9. divided by 1 minus the ratio of 1/3. Again, I'm going to come in and multiply by a fraction equivalent to 1, but a number that's going to knock out both of the denominators. That number would be 9. So 4/9 times 9 is 4. The 9 on the bottom distributes. 9 times 1 is 9. 1/3 of 9 is 3. So we get 4/6, which is 2/3.